Here are some example questions on sketching cubic equation graphs. Let's look at question A. I just rewrite the question here. We have y equals to bracket x plus 3 bracket cube minus 27. Okay. In this graph, we can from the equation we know the graph would have this shape. Okay. Okay. Now let's find the point of inflection first. We find it by x make y in the bracket equal to 0, which is minus 3, and y point of inflection, and y is minus 27. Okay, this is our point of inflection, came from here. Okay, the point of inflection is minus 3 and minus 27. After we have the point of inflection, we can sketch the graph easily. Okay, just do it here. See, this point is minus 3 and minus 27, and our graph would looks like this. Okay. Y equals to point of inflection there, x plus 3 bracket cube minus 27, and from the graph we can see an y-intercept and an x-intercept. So let's find it out. So when x equals to 0 for y-intercept, y would be 3 cube minus 27, which is 0. Okay. So x-intercept, so your y-intercept is 0, and when y equals to 0, we will have x is 0. So okay, so our x-intercept and y-intercept are on the origin, so I have to resketch the graph. Okay. So our graph would look like this, and this is point of inflection, which is minus 3 and minus 27, and then your x and y intercept are at the origin. Okay, just like this. Also, the domain of the graph is x belongs to R, and yeah, that's it. That's how do we solve question A. Okay, let's do question B. In question B, because of okay, I rewrite question B there. Question B is y equals to minus bracket x plus 8 bracket cube minus 8. In graph B, because of the minus sign there, the shape of the graph would look like something like this, because of the minus sign. So here the shape of the graph looks like this. And let's find the point of inflection first. So make y in the bracket equal to 0, x plus 8 equals to 0, x equals to minus 8, and the y will be the y coordinate of the of the point of inflection will be minus 8. Just from here, or you can substitute x equals to minus 8 into the function. We will have minus 8. So the coordinate is minus 8 and minus 8. Now let's sketch the graph. So this is x, this is y. At this point is our point of inflection. If the graph goes this way, let's just draw it. Okay. We will have the graph would look like this. And don't forget to label the domain, which is x belong to R. Okay, we can say we have an x-intercept and a y-intercept. So we try to find both intercept. We assume x equal to 0 to find y-intercept. So our y-intercept is minus 8 cube minus 8, which is around 500. 8 cube 8 cube no, it's minus 520. Sorry, minus 520. So our y-intercept here is minus 520, and we assume y equals to 0. Sorry, this y-intercept. This is minus 520. We assume y equals to 0 to find the x-intercept. We will have 0 equals to minus x plus 8 cube minus 8. So x plus 8 cube equals to 8, and x will be x plus 8 will be 2, and x will be 8 minus 2 minus 8, which is minus 6. So our x-intercept is minus 6. Okay, now that's our graph for question B. It's pretty simple to draw once we have the point of inflection. Okay. In question C, we have an equation y equals to x cubed plus 2x squared plus x. The shape of the graph would look like that because there's a positive coefficient for x cube. And let's factorize it first. So because in the three terms of the function we have a common factor x, each term in the function is a multiple of x, so we just take x out and put the rest in a bracket. Okay. Now we have a x times bracket and a quadratic equation in the bracket. So we try to factorize the quadratic equation, and in this case the quadratic equation fits to a perfect square, which is x plus 1 square. So we factorize it first. Now we try to find the x-intercept and the y-intercept. So let's put x equal to 0, find its y-intercept. We substitute this x equal to 0 in to the function, and we will have y will be 0. So 0, 0, the origin is our y-intercept. Now we assume y equals to 0 to find the x-intercept. We will have 0 equals to x cubed, x squared plus 1. Sorry. 0 equals to x times bracket x plus 1 squared, and x is 0 or minus 1. Only when x equal to 0 or minus 1, we will have y will be 0. So that's your x-intercept. Now let's sketch our graph. So our x-intercept is minus 1 and 0. Also our our y-intercept is 0 here. Okay, so the graph would look like this. So the graph would look like something there. Okay. Okay. Okay, and the domain is x belong to R. So, okay, from this graph we can say we have a turning point at the x-axis, which well, when x is minus 1, will have a turning point. We only have two x-intercepts. Okay, so the general rule I can say in an equation like this, when